word problem. So we are going to take this very slow because I know it's everybody's favorite thing in the world, right? Okay? And even if it's maybe not your favorite thing in the world, I definitely understand that this is one of the more challenging things in math. Because you're like, math is numbers, we're not supposed to be dealing with sentences and phrases and things like that. But word problems are such a great way to show you this is why we do math, right? Actually, kind of as an example, building my canned food sculpture, or helping out with the canned food sculpture for Dom Sob down there, and I wanted to, we're building the White House, and I wanted to figure out how wide and how tall it needed to be semi-accurate to the actual White House. So I wanted the ratio of the width to the height to be accurate. So then I had to figure out, okay, from the ratio in the picture to the ratio in our spot, and then how many cans would that be? I had to do a lot of math. It's a good application, right? Yeah? Okay, so, word problems. Okay, so, applications of linear systems here. For today, I have our two examples here, and I actually think we're just going to do the first three examples over here. Your homework today, you have 3 problems to do on your homework today, because I understand that word problems are a little challenging. So, I think what's so challenging about word problems is there's not like a one-size-fits-all approach to word problems. I can't say, here's your word problem, do this first, and then do this, and then do this, and then there's your answer, because they're all different. So, here's just kind of some I call them steps, but it's kind of more tips or guidelines instead for how to solve word problems, systems of equations. First thing, so incredibly important, read the entire problem through. I have so many students that try to start reading the problem, and as soon as they hit the first letter or the first word, they're trying to write out their problem. Read the whole thing through so you know what information you have, what information you need, what are we looking for, things like that. Okay, next thing. Establish your variables. This is so incredibly helpful, and this is something you are going to have to do on your homework to get full credit. What I mean by establish your variables, if you're going to use A for apples and B for bananas, because that's what you're looking for in your problem, I should see A equals apples, B equals bananas. And we'll kind of come back to that a little bit. That way you know that's what I'm looking for. Okay? Now, since this is a system of equations, think about all the systems of equations we've solved so far. You have an x and a y. Every single problem you've had 2 variables. So when you read through your problem, you should have 2 variables for every single problem. An x and a y, an a and a b, whatever letters you choose, and I don't care, you should have 2 of them for every problem. Next, you're going to read back through your problem, and using those 2 variables, you need to write 2 equations. Think about all the problems we've done. You have 2 variables and you've had 2 equations for every single system of equations. So every single word problems, you should have 2 variables and 2 equations using those 2 variables. Okay? Once you have your equations written, then you have what method you're going to choose to solve. It's either going to be substitution or elimination. Most of the time it's going to be elimination, but there are going to be some of them that are kind of set up to do substitution. We'll see some of those today. Okay? Then you're going to solve. And then the last thing, make sure your answer makes sense. If you get, oh, I got negative 14 bananas. No, right? You can have negative 14 bananas or like 18 and a half apples. You can have 18 and a half apples, but you're probably not going to have 18 and a half apples. Or 8 million miles. Make sure your answer makes sense. If it doesn't, you know you did something wrong. Okay? Now, another thing that I like to do, I'm a big underliner person, so I kind of like to use colors and underline and things like that, so you're going to see that here. So I kind of like to color coordinate things, so you're going to see that. So let's look at this first problem here. So first thing that my step said, we're going to read the entire problem through. Suppose your class sells wrapping paper for $4 per package and greeting cards for $10 per box. Your class sold 205 items in all and earned $1,084 in sales. Find the numbers of packages of wrapping paper and the number of boxes of greeting cards sold. Okay, first thing, checked off. Done, read the whole problem. Second thing, and you're going to have to do this on your homework, establish your variables. What your variables always are going to be is what are we trying to find. Because in math, that's what we use variables for. Information We don't know. So as you're reading through the problem, you might already start kind of thinking about, well, I know this, I don't know this. That's what your variable is going to be. And actually, the easiest way to figure out what your variables are going to be, almost always, it's going to be that last sentence. Because that last sentence almost always says, find this. If you look at the last sentence, it says, find the number of packages of wrapping paper and the number of boxes of greeting cards. Those are the two things I'm trying to find. Those are my two variables. Now, if you want to use X and Y, great. I kind of like to be a little more creative, and I might do, okay, W for, and let's be specific here, number of packages of wrapping paper. Number of wrapping paper. That's the first thing we're going to do. Okay? Number of packages of wrapping paper and the number of boxes of greeting cards. So maybe I use C for number of greeting cards. That's the first thing you are going to have to do on your homework. Okay, next thing, I have my two variables, W and C. W for the number of wrapping paper, C for the number of cards. Now I need two equations using W and C. So we're going to go back to the problem and reread it and see if we can find out how to write an equation. Okay, so suppose your class sells wrapping paper for $4 per package for greeting cards, $10 per greeting cards for $10 per box. That sounds kind of mathy. I mean, there's numbers there. So, okay, $4 per package, sorry, wrapping paper for $4 per package, greeting cards for $10 per box. It's not going to be a complete equation, but let's see if we can maybe write that into math. So when I say wrapping paper for $4 per package, okay, so each thing of wrapping paper, each W costs $4. So if I were to say 4W, let's think about what this would tell us, because that's going to be really important. When I take $4 times W, $4 times the number of wrapping paper boxes I sold. So if I sell 10, I would take 4 times 10 and I'd get 40. If W is 20, 4 times 20 would give me 80. When I take 4 times W, what does that tell me? And what specifically, like when I got 40 what? Like when I take 4 times 10, or 4 times 20, it'd be 40 what? 80 what? Dollars, right? It'd be $40 for the wrapping paper, right? This is the money I'm making off the wrapping paper. Does that make sense? Okay, we can do the same thing here. Greeting cards for $10 per box. So if I do 10C, this kind of tells you the same thing, right? If you sell 5 boxes of greeting cards, 10 times 5, that'd be $50 that you're taking in for the greeting cards. Okay? Now, this is part of my equation, but this has to be equal to something. So this is where you have to be really careful on these types of problems. Okay? So this is the money I'm making off the wrapping paper, the money I'm making off the greeting cards. If I add them together, that's like my total amount of money. Do I know that? Do they tell me the total? They do, right? $1,084 in sales. So that equals $1,084. Okay, so we have one equation down. Now, whenever you write that first equation, write it down, forget about it. The second equation really has nothing to do with that one. The second equation has to deal with your class sold 205 items. 205 items. What kind of items did we sell? Wrapping paper and greeting cards. How much wrapping paper? We don't know. But what do I have to represent how much wrapping paper? Well, that's the money, right? We're not talking about money. What is it? So 205 total. The thing is, I don't know how many of them were wrapping paper, and I don't know how many of them were greeting cards. But I said, well, W is how much wrapping paper I sold, right? So although I don't know what it is, I do have something to represent it. I sold W boxes of wrapping paper, and I sold C boxes of cards. If I sold this many boxes of wrapping paper and this many cards, how many total items did I sell? 205. Okay, once you have your two equations, now you're ready to solve. Now, usually, see how I have the W's lined up, the C's lined up, the equal signs, the constants lined up? You're probably going to use elimination, which means if we are going to use elimination, we're looking to eliminate a variable. I think probably the easiest variable to eliminate here would be the W's. So if I leave this as a 4W, what would cancel out of 4W? Right, so if I do 4W and negative 4W, those would be eliminated, those would cancel out. So the first equation isn't going to change. It's going to say plus 10C equals 1,084. Now the second equation, how do I go from W to negative 4W? Multiply by a negative 4. So we'd have our negative 4W minus 4C. 205 times negative 4, I believe, gives me negative 820. And although it's not x's and y's, this is what we did all last week and the week before. The w's cancel out. 10c minus 4c gives me 6c. 1,084 minus 820 gives me 264. Divide by 6, and we should get 94. Yes.
So why did you just choose the negative and not choose the other things?
I did, didn't I? This was a plus and this was positive. This is negative. Yeah, and this is negative. So yes, we did have to change all the signs there. Okay, now C equals 84. Great, but this isn't just an X and a Y. It's something. C is what? Number of cards. We sold 84 boxes of cards. That's half of your answer. But I also want to find out how much wrapping paper I sold. We did this all last week. How would I find out how much wrapping paper I sold? Plug it in, right? Yeah. If C equals 84, plug it in right here. So let's do W plus 84 equals 205. Subtract 84 from both sides, and we should get 121, which is great, but it's not just an X or a Y, it's a W. 121 what? Boxes of wrapping paper, or rolls, or whatever it was, of wrapping paper that I was talking about. Okay, last thing, let's make sure it makes sense. It's not like a negative. That's kind of a good indicator that you did something wrong. I probably couldn't sell like 1.25 rolls of wrapping paper, so it's a whole number. It's not an obnoxiously big or small number, so I think it'd be reasonable to keep that. Okay? Let's try another one. All right, this one. First thing, read the entire problem through. A company sells brass and steel machine parts. One shipment contains 3 brass and 10 steel parts and costs $48. A second shipment contains 7 brass and 4 steel parts and costs $54. Find the cost of each machine part. Okay, read the whole problem through. Next thing, I need 2 variables. Go to that last sentence. It will usually tell you what variables you're looking for. Find the cost of each machine part. Okay, what kind of machine parts do I have? Brass and steel. So let's use B equals now. When we do this, I'm going to use B and S. We want to be specific, because if I just say B for brass and S for steel, I mean, what am I talking about? Am I talking about the number of brass parts? Am I talking about the cost of the brass parts? Am I talking about how heavy they are? Am I talking the cost? I know how many, right? 3 brass, 10 steel. 7 brass, 4. I know the number. What I don't know, look, find the cost. I don't know the cost of a brass part. I don't know the cost of a steel part. Okay, we have our 2 variables. Now we need 2 equations. Now guys, These are the easiest equations in the world to write. Watch this. Company sells brass and steel machine parts. One shipment contains 3 brass and 10 steel parts and costs $48. Watch this. 3 brass and 10 steel and costs $48. You can like literally take that sentence and turn it into numbers and variables. 3B, 3 brass, plus 10S, 10 steel, and costs equals 48. Just take it exactly as it's written. Do the same thing with the second one. A second shipment contains 7 brass and 4 steel parts and costs $54. So we have 7 brass and 4 steel parts and costs $54. Okay, you have your 2 equations. Now we have to solve. Like the last one, notice how it's all nice and lined up for me, so we're probably going to use elimination. You guys want to cancel out the S's or the B's? The B's? Okay. What can I turn 3B and 7B both into? What? 21. Now remember, I don't want them both to be 21B because those aren't going to cancel out. I need one to be a 21B and one to be a negative 21B. It doesn't matter which one you make positive, which one you make negative, but one of them has to be positive, one of them has to be negative. So for the first equation, how do I go from 3B to 21B? Times 7. 7 times 3B, there's my 21B. 7 times 10S is 70S. And then 48 times 7, 28, 33, 336. Now the second equation, how do I go from 7B to negative 21B? All right, it's going to have to be negative 3. There's my negative 21B. This is going to be my negative 12S. And 54 times negative 3 would be negative 162. Okay, then we add these together. The B's cancel out like we were thinking they would. 70S minus 12S gives me 58S. 336 minus 162 gives me 174. I might need some help here on this. I'm going to have a calculator. Divide by 58. What? 3? Awesome. So S equals 3, but remember the S isn't just an X or Y, it's an S. 3 what? 3. It's the cost, right? It's $3. The steel parts cost $3. So then to find out how much the brass parts cost, plug it into one of the other ones. So I might choose this first one here. Remember we solved for S, so we have to plug it in for S. So we have 3B plus 10 instead of S. Let's plug in 3 equals 48. So 3B plus 30 equals 48. Subtract 30. So 3B equals 18. Divide by 3, we get B equals 6. But it'd be 6 what? $. The brass parts cost $6. Okay, let's get this glued into your table of contents. This should be on page 59. Section. Cut it in half. Sorry, cut it in half because the other half is going to be our examples. And we'll call it application of linear systems. Okay, so the first one, it says the sum of two numbers is 55. Their difference is 29. Find the number. So first thing, I need some variables. This time we're just talking about numbers. So this time I might just say, okay, we've got X and Y. And I really can't be a whole lot more specific than maybe like the first number and Y is going to be the second number. Doesn't really matter which is which. Okay. So I have two variables, x and y. The first thing says the sum of the two numbers is 55. Sum means add. So if my two numbers are x and y, I'm going to take x plus y, and their sum is 55. The second equation, their difference is 29. What does difference mean? Subtract. So you're going to take x minus y equals 29. Those two equations should be pretty simple to write. Okay, now, it's lined up nicely. X, y is equal signs constants. And if you notice, see how it's a plus y and a minus y? That's nice. Let's go ahead and add these together. The y's cancel out. Don't forget to add your x's. X plus x is 2x. 55 plus 29 is going to be 84. Divide by 2, we get x equals 42. Now in this one, I don't really have a label because it's just a number. One of my numbers is 42. To find the other number, make sure we're plugging 42 in for x. So we have 42 plus y equals 55. Subtract 42 from both sides. We should get y equals 13. And this would be an easy one to check. Their sum, 42 plus 13, 55. Their difference, 42 minus 13, 29. Questions on that first one? Okay. The next one. 2 softballs and 5 baseballs cost $15. 5 softballs and 2 baseballs cost $16.50. How much does each softball cost? Okay, I need 2 variables. It only asks for one, but it kind of leads you into what the other ones are going to be. What are my variables going to be? S and B. Now, let's be specific here. I assume we're talking about softballs and baseballs, but what do I not know the cost, right? Because how much does it cost? I don't know the cost of a softball. I don't know the cost of a baseball. Now, these are the equations that are really easy to write. You can see how it says 2 softballs and 5 baseballs cost $15. 2 softballs and 5 baseballs cost $15. The second equation is almost as easy. 5 softballs and 2 baseballs cost $16.50. Who thinks they can write that one? 5s plus 2b equals $16.50. Okay, now technically, I don't know if any of the ones on your homework do this. What does it ask for? It technically only asks for the cost of a softball, right? So I really don't have to find how much a baseball costs. So when you're thinking about what variable should I cancel out, I don't care how much a baseball costs. So let's cancel out the b's. I want to know what does s equal. So we're going to cancel out the b's. What can I turn a 5b and a 2b both into? A 10b. Now remember, I don't want 10b and 10b. Those aren't going to cancel out. I want a plus 10b and a minus 10b. So for the first equation, how do you get from 5b to 10b? Times 2. 2 times 2s gives me 4s. 2 times 5b, there's my 10b. 15 times 2 gives me 30. For the second equation, how do I get from 2b to a negative 10b? Negative 5. And I might need some help here on the right-hand side. Negative 5 times 5s gives me negative 25s. Negative 5 times 2b gives me negative 10b. That's where I need help. 1650 times negative 5. Negative 82.5. Very good, thank you. Notice the b's cancel out. 4s and negative 25s gives me negative 21s. 30 and negative 82.5 gives me negative 5250. And divide by negative 21. I need some help here too. I think I know what it is, I'm not sure. 2.5. But this isn't an x and a y, this is an s. 2.5. $2.50, right? We're talking about cost. Now, this one doesn't ask for the cost of a baseball, so you kind of got lucky on this one. I don't know if that happens on your homework or not, but if it doesn't ask for both of them, you don't have to find both of them. Okay, last one here. Okay, at an all-you-can-eat barbecue fundraiser that you are sponsoring, adults pay $6 for a dinner, and children pay $4 for a dinner. 212 people attended, and you raised $1,128. What is the total number of adults and the total number of children that attended? Okay, first thing, I need variables. What are my variables going to be? Let's do A and C. Now remember, we want to be specific. What don't I know about the adults and the children? How many? Good. I don't know the number of adults. I don't know the number of children. Okay, now, the first one on all-you-can-eat barbecue fundraiser that you are sponsoring, adults pay $6 for a dinner, children pay $4 for a dinner. That's kind of like the last one. This part's pretty easy to write. Adults pay $6 for a dinner, so 6A. Children pay $4 for a dinner, so 4C. Now here's the thing. When you're trying to decide what to set this equal to, you have to be able to go back and decide what information does this give me. When I take 6 times A, when I take $6 times the number of adults, so like if A was 10, it'd be 6 times 10, which is 60. What does 6A tell me? Now, A tells me how many adults were there. When I take $6 times the number of adults were there, does what? How much all of the adults spent, right? This is all of the money from the adults. This is all the money for the children. So if I take all the adult money, all the children money, how much money did we raise? $1,128. Make sure you set it equal to the correct thing. Now the second equation tends to be the one that students struggle with writing a little bit, and it has to do with this. 212 people attended. What kind of people? Yes! A plus C. Adults and children. I don't know how many adults. I don't know how many children, but all the adults and all the children, 212 people. Great. Awesome. Okay, now once you have your equation written, we are looking for both variables this time. So probably just pick one to cancel out. You guys want to cancel out the A's or the C's? The A's? Okay, so we're going to do 6A and negative 6A. The first equation is already a 6A, so we'll leave it as 6A plus 4C equals 1,128. Second equation, how do I get from A to negative 6A? Yeah, multiply by negative 6, so it's going to be negative 6A minus 6C, and then 212 times 6 would be negative 1,272. Okay, the A's cancel out. 4C and negative 6C gives me negative 2C. And then 1,128 minus 1,000. I need help on this one. If you don't mind. 1,128 minus 1,272. 144. Negative 144. Awesome. Divide by negative 2, and we should get C equals 72. 72 what? Children. Yeah, there were 72 children at the barbecue. I still need to find out how many adults were at the barbecue. So this second equation is probably going to be the easier one to do. So we'll do A plus 72 equals 212. Subtract 72 from both sides. You should have 140 adults.